Hey guys, in this video we're just going to go ahead and go over the observations from Castle Unit 5 Activity 1, and then we're going to go into some deeper color coding so that we can understand some of the invisible stuff that we can't see, things that are happening in the wires, and then we'll use that information to go ahead and form a consensus together. So what we saw in this activity was that at the very beginning, at the moment that the wires are connected, bulbs 1 and 4 light very, very bright, which suggests that they have a very high flow rate of charge because there must be a large potential difference or voltage across them. Meanwhile, bulbs 2 and 3 don't light at the moment of connection, suggesting that at that time they have very little or no charge flow, and therefore a very small or no potential difference or voltage across those two bulbs in the middle. As time goes on, bulbs 1 and 4 gradually get dimmer, while bulbs 2 and 3 get brighter, until all 4 of the bulbs have the same brightness and they meet somewhere in the middle. Because the brightness of each bulb is changing, that means that the charge flow through each bulb must be changing. It's also different in each wire, which is interesting to note. And that means that the pressure in the wires must be changing. And if you don't like the word pressure, we can use potential difference or voltage. I'm going to use all three of those pretty much interchangeably. Okay, I want to go ahead and start color coding this circuit at different points in time. So we can start by color coding before any of the wires get connected at all. Now before any of those wires are connected, note that I have it not connected to either side of the battery. Before any of those wires are connected, they all have exactly the amount of charge, exactly the amount of electrons in each wire that are supposed to be there. So none of them are positive, none of them are negative, they're all neutral. They all have this normal electric pressure. Okay, and so we're going to color all of those wires yellow because that is our color that signifies that they all have a normal electric pressure or a neutral potential. Okay, now because all of these wires are yellow, okay, all of them are yellow, there is no pressure difference from here to here. There's no pressure difference from there to there, or from there to there, or from there to there. And so none of those bulbs light at the beginning. Now, at the moment of connection, what we see is that this bulb here lights very bright, and this bulb here lights very bright, which means that there must be a lot of charge flow through that bulb and a lot of charge flow through that bulb, but none through those bulbs. That means that there are electrons that are coming out of this wire and going into this wire, and there's electrons coming out of this wire and going into this wire. But this wire right here, there's not any electrons going in or out of it. It's pretty much just going to stay right exactly the way it is. So that means that given the brightness that we see and the charge flow that we're seeing, that means that, of course, when we connect this here, that's going to be red because that's the job of the battery, is to make that wire that's connected to it red, to make it a high potential. The battery is designed so that it keeps the top of it at a high potential and the bottom of it at a low potential. Okay, now these other wires that are not connected to the battery, no charge has moved in them at all. No electrons have moved anywhere. And so that means that all the rest of these must still be yellow. And that's going to make sense at this point in time because these two middle bulbs, just like we just said, they are not lit. There is not charge flowing through them. And we can see that because all those wires are yellow, that's why none of the charge is going to be moving through there. But something that we do see happening is there are electrons moving from this blue wire into this yellow wire, which means that this yellow wire here is becoming more negative because there's not any electrons moving from here to here, but there are electrons moving from the blue into here, which means that this wire here is gaining electrons. Meanwhile, this wire has electrons moving out of it and into here, but there's no electrons moving into it. Okay, there's not electrons moving into this wire, but there are electrons moving out of it, which means that that wire is going to be getting more positive. And so to show that those wires have a changing pressure or a changing potential, okay, this one right here is getting just a little bit more green. See how I'm using this yellow-green color to show that it's not yellow anymore, but it's also not quite our dark green. We're about halfway through this process, and so that means that the difference from here to here is going to be is going to be greater than the difference from here to here. And we see that at this point in time, bulbs 1 and 4 are lit bright, but not very bright anymore. And these ones at this point are dim. They're not quite as bright as they're going to become yet. Okay, these ones have less charge flow than these ones do. Okay, and that's, again, that's important because that means that there is more charge, more electrons moving from this wire into here than there are moving from this wire into here. And then this wire here, we'll color it this kind of yellow-orange color, for the same reason that the one on the bottom is this kind of yellow-green. It's about halfway in between getting this all the way up to orange and this all the way down to green. Okay, so there's a difference in the flow rate from in here versus here. But then the flow rate through these two bulbs, that's the same because the pressure difference from here to here and from here to here are the same pressure difference. So that's why this one is going to stay yellow, because the same amount of charge is coming into it and the same amount of charge is going out of it. Whereas this wire here, this one is changing because there's more charge coming in, or more electrons coming in, and less electrons going out. And so that's why the pressure in that one is changing. Just to finish this off, eventually this is going to reach its final state where all the bulbs are the same brightness and we see the same charge flow through the whole circuit. Okay, again, this top wire here is going to stay red always, and this bottom wire here is going to stay blue always. But at this point, we've had enough charge come in, or enough electrons come into this wire to bring it all the way down to my green. And we have had enough electrons come out of this wire to bring it all the way up to my orange. And this one here again has stayed yellow because this entire time that this has been going on. The same number of electrons have been going through this bulb as are going out through this bulb. And so this wire here is staying yellow because the same number are coming in as are leaving. At this point, though, the pressure difference from blue to green, and from green to yellow, and from yellow to orange, and from orange to red, all of those pressure differences are the same. And so the flow rate through the whole circuit now is the same flow rate. That means every single wire has the same amount of charge going in as is coming out. And so since the same amount of charge comes in as goes out, at this point the circuit is going to stay like this. All these bulbs are going to stay the same constant brightness now. As a quick consensus here, when we first connected the loop, the flow rates in and out of each wire were not equal. So when we first connect our circuits, the flow rate in and out of each wire might not be equal. Each bulb might actually have a different flow rate. And that unequal flow rate in and out of the wires is what causes the amount of charge in that wire to change. So the number of electrons in the wire changes. If the amount of charge in a wire increases, then the compression or pressure in that wire also increases. So this pressure arises because of an excess of electrons or a deficit of electrons in the wire. So as we get more electrons, we get a lower potential. As we get less electrons, we get a higher potential. And this pressure, this potential in each wire is going to continue to change until the flow rate in and out of each wire is equal. Once it's all equal, the pressure is going to stop changing because at that point we won't have more charge going in as is coming out of different places, and that's what changes the pressure. So obviously once it's equal, that pressure does stop changing. Okay, go ahead and fill out the back of this activity, and I suppose I will see you guys next week or tomorrow, depending on what day you're actually doing this. All right, bye guys.